Okay, this is Mr. Peterson. I'm going to be doing some examples for your review for Chapter 3, Sections 3.1 through 3.3, and this is the first three problems. I've got two examples here that illustrate how to do these problems. Okay, the first one is written all the way out. It says 4.8 times x times y times y. It could be written like this with an exponent on that back half. Now the first thing we're supposed to do is write the coefficient number, and that's the number that's in front of all the variables. So here it's 4.8, and on the next problem it's -3/5. So that takes care of the coefficient part. Part B is the degree, using n to express it. So here n is equal to, you count 1, 2, 3 variables. And it's kind of disguised up here, but there's an x and two y's, so 3 variables. This one, if you wrote it all out, would have x times x, that's 2 variables, and a y times a y times a y. So this one has degree of 5. And then you're supposed to classify it by that degree. Well, the classifications are written over here on the right column, and you can use this chart for your examples. But if it's n equals 3, either 3 x's or an x and a y and a z, or 2 x's and a y, those are examples there, then it's said to be cubic. So this one's cubic. And when it's degree 5, it's quintic. And that does it for problems 1, 2, and 3, both examples. Okay, we'll move on to the next section, and that'll be problems 4, 5, and 6. In this section, we're supposed to simplify the polynomial, and you write down the result in standard form. Once you've done that, you're going to classify it by its degree. So we're going to start looking for the highest exponent we can, and we home in on this x cubed. It's got more variables in it than the other terms, so that's going to go in the front. And then we pick up the ones that have 2x values, 2 variables here, so that's this one and this one, and a 3x squared minus a 1x squared. Those like terms combine to 2x squared, so all we're doing here is in order collecting our like terms. And then we have our minus 8x and our plus 15x, which gives 7x. And finally, this one has a constant value that we haven't accounted for yet, the -1, or the -1. So that one's in standard form. And you look for the term that has the most variables. And it has 3 variables, so its degree is 3, which makes it cubic. And once again, I'm using the chart off the previous page. Let me bring that up again real briefly. Cubic when n is 3. Okay, let's do this next one. It involves some distributing. On the first section, we're multiplying by -2x. And -2x times -5 is positive 10x. In the back, you're distributing the negative sign. And here's the part a lot of people mess up on. Negative times negative is positive. So now I'm going to collect my like terms and put them in order here. It looks like there's only one of them with squared terms, or a quadratic part. And then these two here, they combine to give 4x. And the constant's by itself, so I'll just tack that on the end there. So that one's in standard form now. And the part that has the most x's is this one. It has 2, which if you've got 2 variables, n equals 2, it's called quadratic. So this one's quadratic. And those examples cover problems 4, 5, and 6 on your review. Okay, next we're going to do examples 7, 8, and 9. And what I've got here is just simply 5 problems here. And I've got them in specific order. When there's one term, it's called a monomial, and mono means one in Greek. All right, and when there's two terms, here, let me show you the terms separately, 3x squared and minus 5x. When it's got two terms, it's called a binomial. And when there's three terms, you can separate them by putting slashes in front of the plus and minus signs. Then it's called a trinomial. Above that, this one has 1, 2, 3, 4 terms. Then you just turn generic. You say a polynomial, you can abbreviate, with 4 terms. This one here is an example where there's 1, 2, 3, 4, 5 terms. And it's also the generic version, polynomial with 5 terms. Okay, here's some examples for numbers 10, 11, and 12. I've got 2 examples here. And it's getting a little trickier on this part. You're having to learn what happens on the graph with the right arm and the left arm. Does the right arm go up forever or down forever? That's your first question. And then what happens on the left arm? Does it go up forever or down forever? Okay, start with the right arm. You always do. And what you want to look for is the leading coefficient. Here it's 2. And if it's positive, then your right arm goes up. So you would expect a graph that looks like this on the right arm. Okay? On this one, when the coefficient, the leading coefficient is negative, the right arm goes down. So you may notice that I did the right arm first on both of these, and that's what you have to do. When you're doing this, you always want to figure out the right arm first. Now, the left arm is a little trickier. What it is the degree. When the degree is even, that left arm will mimic the right arm's behavior. So here's one that's even, 4th power. And the left arm is going to do the same thing. It's going to mimic the other arm. So they go the same way. When the degree of the polynomial, this one has x times x times x, so the degree is 3. When it's odd, let me put even on the other one, then the left and right arm go in opposite directions. So here the right arm's going up, the other one goes down. So odd powers have opposite arms. Even powers have the same direction, arms that go the same direction. Okay, let me do one more set of problems here. This is examples 13 and 14. And what you're going to do on this is find the first value, find the relative max and mins on a calculator. So we're going to graph this and basically find the hilltops and valleys. So let me start by turning on my calculator and going to my y equals key. I'm going to type in the function. Okay, so I've got the function typed in. Now I'm going to say zoom 6 for the standard screen. And I could probably get away with finding that hilltop and that valley without making any changes, but often you'll have to magnify the area you're trying to look at. So I'm going to show you how to do that right now. You hit the zoom, choice number 1, which is zoom box, and your cursor will blink on the origin. It's a little hard to see in this video, but it's blinking right on the origin. I'm going to move it over to the left, and you'll see it when I move up. And I'm going to put that thing, park that thing northwest of the origin right there. When you hit enter, it turns into a box that can then be stretched. I'm going to stretch it to the right. And once I'm over here, I'm going to stretch it down. And once you get this box, if you hit enter, that part of the graph will go full screen on you. So I'm going to hit enter and you'll see it better. Okay, this I had a link up there, but it stopped. I don't know if you noticed that. So we're going to find this maximum value here. It's a hilltop. So maximum height, we're going to find it right now. Now, heights are always y values. So when all's said and done, we're going to be finding an approximate y value for that hilltop. The steps are: second, calculate. You'll find that above the trace key. And if you're looking for a hilltop, you want choice 4. Then you take your cursor and you move it to the left side of that hill. You can see my cursor moving, and once you're definitely over on the left side of the hill, hit enter. Then move to the right side of the hill and hit enter twice. You'll see your answer down here. Y is 4.48, and that's an approximate value. So that's the best the calculator does, is give you approximations. And now we'll find the minimum height, and that'll be the minimum height in that valley. There is technically no minimum height, because if you come over here on this wing, that goes down forever. So what we're saying is the minimum height of the valley. Okay, you go second, and once again above the trace key, calculate. But you choose the third one down this time, and hit enter. Now you want to scroll. When it says left bound, you want to scroll somewhere on the left side of the valley. You can see it says left bound, and I'm on the left hand side of this valley. Hit enter. Now once you go to the right side of the valley, once you're definitely over there, hit enter twice. And that goes right past where it says guess. And you'll find that this has a minimum height of -5. So that one I don't think was rounding. I think it was probably exactly -5. But most of the time you'll get decimals when you do this. Okay, I'm going to do another example over here. This time it'll have a couple more hilltops and valleys, I think. So I go to my y equals key and clear out the old function. Type in the new one. Hit zoom 6 to get started. And I'm going to magnify this part of the screen with zoom box. So zoom number 1. Use your cursor, move it around till you find it, and then move it maybe about right there. Hit enter. You'll see a box show up. And expand that box until it's bigger. You want to stretch it to the right and then stretch it downwards until you're covering the area of interest. When you hit enter, that part will fill the screen. So here it comes. There's a valley and a hill and another valley. So we're going to have 2 minimums and 1 maximum. Let me set it up here. And the dots above the equal signs are just approximate. You could do this version if you prefer. Okay, let's find this maximum right there. Second, calc, choice 4. And scroll to the left side of the mountaintop. Hit enter. Go to the other side. Now you're going to hit enter twice. And you can see that you've got a maximum at a height of 3.2. I'm going to say 3.20 to indicate that we're looking at 2 decimals of rounding. Excuse me, I had to get a drink there. Okay, the valley over here we're going to do next. Second, calculate choice 3. Scroll till you're on the left side of the valley. Hit enter. Scroll to the right side of the valley and hit enter twice. That's at about, that's a height of 2. Once again, I don't have to round there, but I'm just going to put that on there to say we are trying to round to 2 decimals. All right, let's find this valley here. Second, calc, choice 3. Scroll until you're on the left side of that long valley. I could actually stop right there, but I'm going to come down a little closer to the bottom. Hit enter. Scroll to the other side. Once you're climbing, hit enter twice. And we get -2.45 for that one. And that takes us through problem number 14 on your review, and I'll pick up on another video to keep this one about 15 minutes.